Good day once again. It is Ishola Adedeji Michael and it is Success Enlightenment. Today on Success Enlightenment, we will continue our discussion on calculus. And the aspect of calculus we started treating here is the differential calculus. And we've so far explained what is differential calculus. We've discussed differentiation through the first principle. Now we want to get to the rules of differentiation. It is of importance for us to know that after a while we've been differentiating with the first principle, then we discover that some things can be generalized as basic rules of differential calculus. These rules makes differentiation easy. That is, they are substitutes to you differentiating through the first principle. A mastery of these rules makes solving calculus problem faster and easier. And in this video, we'll be looking at the constant function rules of differentiation. We'll be discussing the power function rule of differentiation. We'll be discussing the sum and difference of function rules of differentiation. We'll be discussing the product of a function rule of differentiation. And we will be talking on the quotient of a function rule of differentiation. Each of these rules will be discussed and illustrations should be taken as regards the rules. Students should focus majorly on mastering these rules, get an understanding of the rules, and also know that if you differentiate through the first principle, any question, the resultant, which is the derivative of the function given, you differentiated using the first principle. If you also apply any of these rules in differentiating that same function, you will still get the same answer. And with that being said, let's continue. Function rule of differentiation. Now, what do you mean by the constant? A constant, if you are given a function such as y equals to f of x equals to 5. Here, 5 here is a constant because there is no variable attached to it. If you are given 5s, this 5 here is not a constant since there is an s which is a variable attached to it. It's not a constant, but in the case where we are given this as a function, just 5, then this 5 here is a constant, and this is a what? Is a constant function. It's a constant function. The constant function, a graph of this function will look thus. If this is our y, if this is our x, what this function is that what this function says is that y is always what? 5. Is always 5. That's what this is saying. Irrespective of the value of x, our value of y is always 5. This is the word constant function rules. Now, how do we differentiate the constant function and what is the constant function rule? Let's take this to the first principle. Let's take this to our knowledge of first principle of differentiation. Don't forget, if you have something like this and we have to differentiate through the first principle, what we do is what? We find y plus change in y as a function of s plus change in s. Then here we have y plus change in y equals to f of s plus change in x. And this, if we anywhere we see, let's take this equation 1, anywhere we see s, we substitute s plus change in s here, but in this case there is no s, so which means this will still be what? 5. And the next thing we do is what? For us to find our change in y, we subtract our y from both sides. So change in y will now be what? 5 minus y. Recall that our y is f of s equals to 5. So we substitute 5 for y here. So our change in y equals to what? 5 minus 5. So which means our change in y equals to 0. Then change in y, from the graph we draw, see that the y is not changing. It's an horizontal line. It's not changing. So change in y over change in s equals to 0. Then the derivative, which is the y dx, which is the limit of delta y over delta x when delta x tends to 0 it equals to what? Limit of 0 when delta x tends to 0 is same thing as what? 0. Now what this is telling us is that what? The derivative of a constant is always equals to 0. This is what we now call what? The constant function rule of differentiation. What this rule simply tells us is what? The derivative of a constant is what? Is 0. If you are given y equals to 100, so the y, the x will automatically be what? 0, simply because the derivative of a constant function rule of differentiation tells us that the derivative of a constant is equals to 0. And you can always prove and verify this using the first principle. You can always prove and verify that using the first principle. The rule simply says the derivative of a constant is equals to 0. And any function you have that it is just a constant, you see the constant there, so the y ds of that constant will automatically be equals to 0. That is the constant function rule. The second rule of differentiation that we'll be talking on is the power function rule of differentiation. Now, just as the constant function rule is, now we are discussing the power function rule of differentiation. It's very simple. When you hear a power, anywhere you hear power, we are talking of indices, exponentials, as an exponent. When you have let's say y equals to f of x equals to such as we have s raised to power 2. This is s in power of 2. Now these rules guide us on how we can differentiate this. Now we prove this going back to our first principle. We can solve this to our first principle, which goes like, when we have this, the next thing we do is what? We find the y plus change in y as a function of s plus change in s. So therefore we have y plus change in y equals to f of s plus change in s. Let's call this our equation 1 equals to, when you see s, you replace by s plus change in s, which means we have s plus change in s all squared. Now when you add this, we call this equation 2. So let's open this bracket, then we have y plus change in y equals to s plus change in s, s plus change in s. This is also equals to s into bracket s plus change in x plus change in s into s plus change in x. So therefore we have y plus change in y equals to s squared plus x change in s plus s change in s plus change in s squared. So we collect the like times, this is equals to s squared plus 2s change in x plus change in s squared. Now from here, we want to find our change in y, so we subtract y from both sides. So our change in y equals to s squared plus 2s change in s plus change in s all squared minus y. Recall that our y is equals to s squared, y equals to s squared, so we substitute s squared for y here. So we have s squared plus 2s change in s plus change in s all squared minus s squared. This takes this out. So therefore our change in y equals to 2s change in s plus change in s all squared. So we have to find our difference equation, that is change in y over change in s, by simply dividing everything here. Call this equation 3, divide everything in equation 3 by change in s. So therefore change in y over change in s equals to 2x change in s over change in s plus change in s square over change in s. This equals to what? 2s plus change in x. So from here, we find the dy dx by simply taking the derivative of this. That is, we find the limit of change in y over change in s when change in s is tends to 0. So therefore, from here, what we have is what? Dy dx equals to limit change in y over change in s equals to limit of 2x plus change in s as change in s tends to 0, change in s tends to 0. Whenever you see change in s, you replace it by 0. Therefore, dy dx equals to 2x. We have 2x. Now let's solve more. Let's solve just one more question. Then after solving just one more question, we are going to then talk about what the power function rule. Let's say, for instance, instead of us being given 2s squared, we are given, instead of us being given s squared here, we are given 2s squared. Let's say we are given 2s squared. What then will be the derivative of this function? What will be the derivative of the function y equals f of s equals to 2s squared? Still the same procedure. Y equals to y plus change in y equals to f of s plus change in x equals to 2 into s plus change in s all square. Equation 2. Then from here we have y plus change in y equals to 2 into, we've already opened this bracket the first time, so we already know what we have here, which is what? S square plus 2s change in s plus change in s square. So this is what we have here. So from here, we can multiply everything here by 2. So we have y plus change in y equals to 2s square plus 4s change in x plus 2 change in s square. So from here we subtract y from both sides. So change in y equals to what? 2s square plus 4s change in s plus 2 change in s square minus y. Recall that our y is 2s square, so substitute this for y here. So we have 2s square plus 4s change in x plus 2 change in s all square minus 2s square. Automatically this takes this out. So therefore our change in y will then be equals to 4s change in s plus 2 into change in s square. So what we do here is we find our difference quotient by dividing both sides by change in x. That is, change in y over change in s will now be equals to 4s change in s over change in x plus 2 into change in s all square over change in s. This will give us 4s plus 2 change in s. So this is our difference quotient. So from here, all we do is what? We find the dy dx of the function given, function y equals to 2s squared, by taking the limit of change in y over change in s when change in s tends to 0, which is then equals to the limit of 4s plus 2 change in x as change in s tends to 0. Whenever you see change in s replaced by 0, so therefore dy dx equals to 4x. Now, if you look at the two questions we have solved, we can make a generalization based on them, and this generalization is what we call what? This generalization is what we call the power function rule of differentiation. What we have the first time, we have y equals to s squared, and the dy dx equals to 2x. Now the second time we have y equals to 2s squared and the dy dx equals to 4x. By rule of differentiation, by the power function rule of differentiation, what this rule says is that when you have a function such as y equals to cs raised to power n, now the dy, the x of this function will now be equals to c times n s raised to power n minus 1. That is cn s raised to power n minus 1. This is the power function rule of differentiation. This is the power function rule of differentiation. And if you apply this rule here, we get the same thing. Now here we have the coefficient of our x here is 1. So therefore our n is 1. So if you apply, our n is 2 and our c is 1 from here. So you apply this rule, what we have is what? It will be 1 times 2 into bracket s raised to power 2 minus 1, which equals to what? 2s raised to power 1, which is same thing as 2x. Now if you apply this also to this second one, we have what? Our c is 2, which is the coefficient of s squared, and the n here is 2, which is the power of x. So therefore we have what? 2 times 2 into bracket s raised to power 2 minus 1, which is same thing as 4s raised to power, well, it is as 4s. Definitely, when we solve this using the first principle and when we apply the power function rule, we get exactly the same derivative for the function. So therefore, the power function rule of differentiation says that when you have a function that is raised to a power like this, so what you do is what? You multiply the power by the coefficient of the variable. So when you multiply the power, then you multiply by then you have the x, you subtract 1 from the power of the what? Of the variable. So this is the power function rule of differentiation. It is very, very important rules that shouldn't be forgotten by any student willing to have a mastery of differential calculus. Here we look at the third rules of differentiation, and this is called the sum and difference of a function rule of differential calculus. Sum and difference of a function rule of differential calculus. Now in calculus, we could have sum of a function, and we could also have difference of a function, or we could have sum and difference of a function together. For instance, we can have y equals to f of s, such as we have 3s squared plus 2x minus 4s squared. Now, this is a power function rule. This is a power function rule. This is a power function rule. But here we are. This is a sum, and this is also a difference. So in this case, how do we differentiate this function? Now, we already know how we can differentiate this function through the first principle. But you and I know the first principle is cumbersome. It is time consuming. So if you are given this, how do you do with it? How do you do with it? Now, let's assume we have y equals to f of s equals to u plus phi. I say this is what we are dealing with. Let's say we are given y equals to f of s equals to u plus phi. Note here, your u must be expressed in x, and the phi has to be expressed in s. So in case that your u is not expressed in s, anything you are dealing with here will be a constant. It will be a constant. Since as far as this is concerned, we are dealing with y as a function of x. For instance, let's say you have y equals to 5p, and you are asked to find the derivative of the dy dx. Definitely there is no s here. So the fact that there is no s here make everything here a constant. So therefore all you have here is what? Is 0, derivative of a constant function rule. But in case you have y equals to 5, so in case you have y equals to 5px, now you already have x here. So now dy dx will be equals to what? 5p. So that's it. But here your u has to be expressed in s and your phi has to be expressed in x. So if you have this like this, then you can find y plus change in y will now be equals to what? U plus what? Change in u, that's the new position, plus v plus change in v, that's the new position. You know, you are supposed to look for y plus y plus change in y is function of s plus change in s, and whenever you see x there, you substitute what? S plus change in s. But recall your u is expressed in x, which means we can also write this as x. So now going further from here, it's still the same procedure with first principle. From here, our change in y, if we subtract y from both sides, then this will be u plus change in u plus phi plus change in v minus y. Recall, our y is u plus phi, so therefore we have u plus change in u plus phi plus change in v minus u plus phi in bracket. So change in y equals to u plus change in u plus phi plus change in v minus u minus phi. So this takes this out and this take this out. So therefore change in y equals to change in u plus change in v. Now our difference quotients here will be what? Change in y over change in s. Therefore we divide all through by change in x. So we have change in u over change in s plus change in v over change in x. Now this difference quotient, now we find the derivative of the function y is equal to u plus v, which is dy ds, which is the limit of change in y over change in s when change in s tends to 0. Now this will then be equals to what? Du ds plus what? D phi dx. Now what this is telling us is this. Now to find the derivative of a sum of a function, the rule is simple. All you have to do is what? You find the derivative of the first function, then you find the derivative of the second function, then you add them together. In this case, we have 3s squared, we have 2s. Now the derivative of 3s squared using our power function rule will be 3 times 2 x raised to power 2 minus 1, which is equals to 6x. Now derivative of 2s will be what? It will be 2 times 1 s raised to power 1 minus 1, which will be 2. So therefore the derivative of 3s squared plus 2x ds, this is our u, ds will then be equals to what? 6s plus 2. So what we are having is u minus phi. Instead of plus here, we are having a minus here. How do we go about this? Still the same thing. Y plus change in y equals to u plus change in u minus, that's the only thing that's changed, v plus change in u. So your change in y will then be u plus change in u minus phi minus change in u, or minus y. So our y is u minus phi. So therefore we have u plus change in u minus phi minus change in u minus into u minus phi. So here our change in y equals to u plus change in u minus v minus change in u minus u plus phi. So this takes this out, this also take this out. So therefore our change in y then equals to change in u minus change in v. Let's not forget this is phi, this is phi, this is v. Yes, this is v, this is v. So our change in y over change in x then equals to change in u over change in s minus change in v over change in s. So the y, the s equals to limit of change in y over change in s equals to du dx minus the phi dx. Now if you want to illustrate this by this, we have 2x minus 4x squared. So you find the derivative of this with respect to s and find the derivative of this with respect to s, then we subtract it. In this case, what we have is what? Ux. So we have what? U 2x, derivative now be what? Of this is what? 2 times 1 into s 1 minus 1 is empty as what? 2s raised power 0 equals as 2. And here we have minus, we have 4s squared is empty as what? Derivative be 2, yes, 4 times 2, s raised power 2 minus 1 is empty as what? 8s raised power 1. So therefore, this will be 2 minus 8s. That will be the derivative. So what this is simply saying is what? We find the derivative of the using power function rule, we find the derivative of the using power function rule, and find the derivative of the using power function rule. Then what we get here, we add it with what we get here as the derivative, then we subtract off from what we get here as the derivative. Now to get this clearly, we are going to illustrate it. Now this is sum and difference of a function rule. Now don't forget, if you are given y equals to u plus v, so your dy ds is equals to what? Du dx plus dv dx. And if you are given y equals to u minus v, your dy ds equals to du ds minus dv ds. This is the sum and difference of a function rule of calculus. Now applying this rule here, the derivative of this using the power function rule will be what? Will be 8 dy dx here will now be what? Derivative of what? 8s raised power 4 dx plus derivative of 5s squared dx plus derivative of x dx minus derivative of 10 dx. Are we together? Now from here, the derivative of 8s raised to power 4 ds is a power function rule, so which is equals to 32s raised to power 3 plus 10s raised to power 1 plus s raised to power 0 minus 0. Anything raised to power 0 is equals to 1. So therefore, we have 32s raised to power 3 plus 10s plus 1. Now, this will be the dy dx of 8s raised to power 4, 5s squared plus s minus 10. I want us to solve one more example to illustrate this. Use one more example to illustrate this. We are given y equals to 2s plus 6 in bracket plus another bracket 3s squared plus 4. And this is also a sum and difference of a function rule of differentiation, since this doesn't have any power greater than 1 on it. So from here, what we do is we write this function as y equals to 2s plus 6 plus 3s squared plus 4. I can further this addition. And I can find derivative directly like this. Now, if I find derivative directly like this will be dy ds equals to the 2s plus 6 ds plus the 3s square plus 4 dx. Here the derivative of 2s plus 6, this is a power function rule 2 times 1 s raised to power 0, so this will be what? 2. The rate of a constant is 0, so we have 2 here, 2 plus 0. Then this is what? 6s. This will be 6x. The rate of a constant is equal to 0. So therefore, what we have as the final answer is what? Is 2 plus 6s. And also, if I don't want to solve it this way, I can open this and solve it directly, and I will get the same answer. This is the same thing as what? 6. This is the same thing as what? 3s squared plus 2x plus 10. So I can find the derivative of this, which is dy ds equals to the 3s squared ds plus the 2x ds plus the 10 dx. This will be 6x plus 2 plus 0. So therefore, the answer is what? 6s plus 2. Now, if you remember commutative, you tell that addition is what? Is commutative, which means 2 plus 6s is equals to 6s plus 2. So therefore, you have the same answer, which means if you are given a question like this, you can find the derivative directly like this, or you can expand, you can open this directly, collect your like times, have it in this form, then find the derivative directly like this. Now, most students, when they are solving directly like this, they made mistakes. They made mistakes. So it's sometimes preferable to just go like this and solve it directly like this. But note, don't forget your d3s squared ds plus d2s ds plus d10 ds. That gives you a full mark on solving sum and difference of quotient, sum and difference of a function rule of differential calculus. The fourth rule of differential calculus we'll be looking at here is derivative or product of a function rule of differentiation. This is another very important rule. We need to master that. Suppose we're given y equals to uv. And this is a product because now it's not more addition, it's not u plus v, it is u times v. Now recall that we are finding the y ds, which means your u is in terms of x and your v is also in terms of x. So here we have y plus change in y equals to u plus change in u into bracket v plus change in v. This equation 1, this equation 2. We are still proving using the first principle. So from here we can expand this bracket by saying y plus change in y will be what? U into v plus change in v plus change in u into v plus change in v. We can expand these dots. We have this will be uv plus u change in u change in v plus v change in u plus change in u change in v. Then simply by multiplying this by this give us uv, this by this give us u change in v, this times this give us v change in u, and this is change in u change in v. So this will be our y plus change in y. So from here we can find our change in y by subtracting y from both sides of the equation. So going forward, what we simply do is we have change in y equals to uv plus u change in v plus v change in u plus change in u change in v minus y. Recall our y is uv. So therefore we have uv plus u change in u plus v change in u plus change in u change in v minus uv. This take this out. So therefore our change in y is equals to u change in v, this is v, this is v, plus v change in u plus change in u change in v. So what we do from here is what? We divide both sides by change in s to find our difference quotient. So therefore we have change in y over change in s, which gives us what? U change in v over change in s plus v change in u over change in x plus change in u change in v over change in x. So from here what do we do? From here what we do is what? We find the derivative of this function, because we already getting our difference quotient by taking the limit of our difference quotients. So what we simply do is what? We find the limit as what? As change in x, change in u, and change in v tends to 0. That's what we do here. So therefore our dy ds equals to limit of change in y, change in s, as change in s tends to 0 equals to u dv dx plus v du dx. Everything here will be equals to 0. Everything here will be equals to 0 because the v dx as the ds tends to 0 is same thing as what? Delta change in y over change in s as change in s tends to 0 is same thing as what? Dv dx as change in s tends to 0 is same thing as what? Dv ds. But as change du dv over change in u over change in u change in v divided by change in s as change in u change in v and change in s tends to 0, this equals to what? 0. So therefore the derivative will be u dv ds plus v du ds, and this is what we call the product function rule. This is derivative of product function rule in differential calculus. Now if we relate this to what we have here, it means that when we are given a function that's a product, what we do is what? We take the first function given, we find the derivative of the second one, the product of those together, then we add it to the what? Derivative of the first function times the later function. So we illustrate this so we get exactly what we are talking about. Suppose we are given a function y equals to 4x raised to power 3 minus 2 is a function times another function x squared plus 5x. Now let u equals to 4x raised to power 3 minus 2 and v equals to x squared plus 5x. So we can say y equals to uv is what we are given. So therefore recall from the law of product of a function rule of differentiation, if you are given this, so dy dx will then be what? U dv dx plus v du dx. So therefore dy the x here is what is the u? U is 4s raised to power 3 equals to 4s raised to power 3 minus 2 into derivative of x squared plus 5x dx plus v, which is x squared plus 5s into bracket d 4s raised to power 3 minus 2 dx. Now, what will be the derivative of this? Because using the power function and sum of function rule, this will be what? 2x plus 5. So therefore, we have 4x raised by 3 minus 2 into bracket 2x plus 5. That is, find the derivative of this, plus x squared plus 5x. We find the derivative of this, which into bracket, what do we have here? We have 12x squared. This will be 0. This is 12x squared. So the product of this is what we need now. So the product of this will be, so let's open this bracket. We have what? Let's say we have let's use this to open this. We have 2x into 4x raised by 3 minus 2 plus 5 into 4x raised by 3 minus 2 plus 2x squared times x squared. We have what? 12x raised by 4 plus 5x raised by 3. So here we have equals to 8x raised by 4 minus 4x plus 20x raised by 3 minus 10 plus 12x raised by 4 plus 5x raised by 3. So when we collect the lifetime, we have 8x raised by 4 plus 12x raised by 4. So we have 20x raised by 4, 20x raised by 3 plus 5x raised by 3. We have plus 25x raised by 3. Then we have minus 4x. Then we have minus 10. This will be the what? The y, the x of y equals to 4x raised by 3 minus 2 x squared plus 5x. Now we continue with the quotient rule of differentiation. Now if you're given y equals to u over v, so this we have using the first principle, y plus change in y equals to u plus change in u all over v plus change in v. So from here we can find our change in y, which is change in y equals to u plus change in u all over v plus change in v minus y. Our y is u over v. So from here we can find LCM, which will be v plus change in v onto v. So from here, our change in y equals to v into u plus change in u minus u into v plus change in v, everything divided by v into v plus change in v. So we can open this bracket. So we have u, we have vu plus v change in u minus vu minus u change in v all over v squared plus v change in v. So this take this out. So therefore our change in y equals to v change in u minus u change in v all over v squared plus v change in v. Here we can find our difference quotients by defining both sides by changing x. So therefore we have our different quotients though. So we have v du dx minus u dv dx all over v squared plus v dv. So here we take the derivative of this as changing x tends to 0 du change in u, change in v tends to what? 0. So therefore, the y, the x here will be v du dx minus u dv dx all over v square. As dv tends to 0, this is equals to 0. So this is our quotient rule of differential calculus. This is our quotient rule of derivative. If you have y equals to u over v, so dy ds will be v du ds minus u dv ds divided by v square. Popularly, this is how we have to say it. We need to say we have bottom the top minus top the bottom over bottom square. Now this is the top and this is the bottom. So once again we say we have the bottom the top minus top the bottom over bottom square. That's the quotient rule of differentiation. Let's try and take an example solving using the quotient rule of differentiation. Let's take this example. Suppose we have y equals to 3x squared plus 4 divided by x squared minus 3 as our function to differentiate. This definitely the division here makes it a what? A quotient rule. So to solve this question, the first thing we say is what? Let u equals to 3x squared plus 4 and v equals to x squared minus 3. So from here, then this y can be written as what? U over v, which our quotient rule can be applied, which is dy ds equals to v du dx minus u dv ds over v square. So in this case, what is our v? Our dy ds equals what is our v? Our v is x squared minus 3 du, which is d of 3x squared plus 4 dx minus what is our u? Our u is 3x squared plus 4 dv, which is x squared minus 3 dx. Now, what will be the derivative of this and what will be the derivative of this? So we have x squared minus 3 into what? This will be 6x. This will be 6x minus 3x squared plus 4 into this will be 2x as 2x. So from here, all we do is what? We open this bracket, which will be what? This will be 6x raised to power 3 minus this will be 18x minus this will be 6x raised to power 3. This will be plus 8x. So here we have 6x raised to power 3 minus 18x minus 6x raised to power 3 minus 8x. So this takes this out. So dy ds equals to this, take this out, then we have minus 18x minus 8x, that will be minus 26x. Now recall, everything is divided by phi square. Here we have phi square here. Here we have phi square here. And here we have phi square here. So we deal with the numerator. So we bring in the denominator now. So what is our phi? Our phi is s squared minus 3. So we have v squared minus s squared minus 3 all square here, which is the same thing as what? Minus 2x 26x all divided by x square minus 3 x square minus 3. And here is our final answer, which is the derivative of 3x squared plus 4 over x squared minus 3. I hope this is simple enough. We are going to try and solve some questions that we actually illustrate these 5 laws, and I will suggest that everyone out there watching this video should take their time and solve more questions in this respect. So whichever questions you attempt and you couldn't solve, you find it difficult based on my explanation to solve, feel free to send those questions through the comment section or message me directly on my WhatsApp line, so I can share those questions with me. Then I can take my time to solve them and share them to you and to the world. Thank you. Don't just watch, like and subscribe to the channel. Thank you.